Alright, making a video, I think. Yeah, frame rate just went down. So maybe this won't work. Different camera. Yeah, I guess it's too much high resolution for this computer. Anyway, um, yeah, so I'll probably have to go back to the low resolution camera. Anyway, alright, I have to figure out how to drop the frame rate on purpose or something. Yeah, it's just one thing or another, always. Sorry, I'm supposed to be making a video. Alright, yeah, having just a little buggy today. Alright, took some notes. And, you know, so this guy, Steve Scully, and so some, uh, apparently, chick, had this guy make a response video to my most important video ever kind of thing where I'm trying to explain the theory in a nice 17-minute video. You know, apparently that's too long because people can pay attention for about that long and that's it. So anyway, it's the usual stuff. I mean, I'm looking to replace conventional physics and their silly model with a much more rational model. I'm really not interested in debunking people's infinity theories, their unicorn theories, their wavicle theories, their ether theories, whatever other crap they believe in for which there's zero evidence that it actually exists, and their models are preposterously inefficient at describing anything like electricity and magnetism and gravity. That's sort of the objective here, is to come up with a model to replace a silly model. Okay, I mean, their model is silly. You don't come up with another silly model. So they have bent space for gravity and virtual photons for magnetism and electricity, which is utterly useless as explanation. It doesn't say anything, doesn't explain how either of those things work. And my model does, in a very simple mechanical way. And so, I mean, you know, it just seems rather futile to have a conversation with somebody who's going to say, no, God created human beings. You know, and I'm saying, no, I think all the evidence points to evolution, and this is, I've explained it in my videos how evolution makes sense. It adds up. When you add up what's going on, there's little bits going the speed of light, and there's the matter bits are going much slower, and clear distinction between those two kinds of things. So, I mean, this guy's arguing there's an infinite speed somewhere. We don't see it anywhere because it's, you know, it's down in the little universe somewhere, the whatever, c squared crap. Like, I could care less if there was. How does it explain how a magnet works? I don't think the Hoobies, you know, circling the master galaxy around the whatever, the neutrino, they're not going to change any of the facts in this universe. So, you know, because they're going so fast, the trillions of years go by, you know, and nothing happens here. You know, it's less than a half a second in our world. So why should we care about that? I mean, you're interested, that's fine. I'm totally uninterested in making up fables about the first bubble gum in the universe. Like, what's the first piece of bubble gum, and is there blue bubble gum and green bubble gum, and all, you know, why bother with all that crap if it doesn't have some relevance to the phenomenons we see in this universe? So anyway, you know, again, everybody just cares about doing origin theories. I just couldn't care less. I believe in evolution. I don't need to know exactly how the first DNA molecule was made. Just don't need to. I know enough physics to say, yeah, it's perfectly within the realm of possible that such a molecule could exist. So why do I have to have all of that information? The much more interesting story is how does it evolve into, you know, sentient conscious organisms. Much more interesting subject. So, you know, all right, so he starts off just saying my theory's wrong because it's not infinite and I don't have infinite speeds. Well, why would I bother doing that when every experiment indicates that these forces have consistent slow speeds? Then he says gravity is instantaneous. Well, the evidence against that is that all the models, Newton's math, everybody's math, works better. That is, it's more precise if you tune it to the speed of light. So if you make all the observational data and do all your calculations of distance and include the speed of light, the end result of your equations is a model that works better. That is, it predicts more precisely the future. So it seems if the model is going to work better if you include the speed of light, that it's the speed of light is the speed of gravity. Do you have a counter argument? I mean, why do you believe in stuff that there's no evidence for? So you say there's instantaneous gravity. Where's your evidence that it's instantaneous? Why do you believe it? All right, so right there, the conversation is completely broken because he's going to worry about how fast the speed of light is, and he's going to say that somehow it matters. It matters if there's some invisible particle for which we know doesn't do, we have no accounting for what exactly its function is. That if it was flying through the universe twice the speed of light, what would the relevance be if it didn't create any consequence or effect? And you're not going to find that faster than light particle that's creating any effect, so why should I include it in my model? Why should I waste my time putting four-headed rabbits in the story if I don't need them? Alright, anyway, it's just really so he goes into this relativity thing in the idea of the Earth. He says the Earth could be a black hole from somebody's perspective, or a sun, or this or that, depending on where you are in the universe. It's like, no, the functions are kind of precisely, they have properties. So, I mean, a rhinoceros can't be, from somebody's perspective, a platypus. And it can't be some other, because it has properties. And you have to account for the properties that things have. So, again, what's the point of having a conversation if you're not going to accept that things have properties? And you can't just say it's doing two different things at the same time. It's absorbing energy and it's releasing energy. It's doing this, it's doing... No, it can't be doing both of those things from any perspective. So what's the point of that kind of conversation? It's just a waste of time, in my opinion. Alright, yeah, so it's all this Horton Hears a Who-averse, and so it's all, anybody can make up some silly story about what's happening where we can't measure something. But what's the point? I mean, unless you're making up a property for the purpose of explaining, for example, why magnets work, then what's the point of it? So show me how your theory makes the universe make more sense. Show me how, draw me your diagram of how a magnet works with all of your, how the Hoobies make it happen. Show me where your infinite universe has some relevance to this crap, which I don't think you can do. And then I'll ask you to explain, well, if that's true, if you're saying there's this force doing this, or there's swirly stuff, why can't we detect the swirly stuff? Because certainly if it's moving stuff, we can put stuff that it moves that we can see and watch it move the stuff we can see. And we don't see any of that. So, whatever. Alright, yeah, so I wrote down what evidence compels such belief. I mean, they assert it. I mean, he's aggressively saying, no, that's not the way it is. Well, you have to show me why that's not the way it is. You have to explain how you have a piece of, why should I believe in stuff just because you say so? Oh, well, that's not a good enough reason. Not even close enough to a good enough reason. Let's see, something what we can see. Talk about what... yeah, so, I don't know. So, this is all about imagination, and he even says the word thought experiment or something, and it's like, well, it's fine, but I mean, why should I thought experiment about stuff that's completely meaningless and that doesn't have anything to do with electricity and magnetism and how gravity and how things work? I mean, it's just not interesting. So he agrees that about pressure, but agreeing about pressure and then understanding the difference between charge, because that's the other thing. They just want to turn it into a, well, negative is the pressure is going in you, and then the positive is the pressure is coming out of you, or you're going right, you're going clockwise, or you're going counterclockwise. And I've already been there and done all that crap, and it really doesn't work. It doesn't explain charge, and it won't work in a magnet. So I'm just saying, go ahead and show me how it works. Draw me the working model with those concepts as being all you use to create the phenomenon, and I'll say you'll fail, because I've spent 7 years looking at it, and none of those models can work. Alright, anyway, assuming steady state. see, I wonder what he was saying that in reference to. So he's well, of course, I'm assuming properties is what I'm assuming. So I'm not assuming any steady state. I'm assuming that everything does have properties, and based on mechanism. And I've reduced it to 4 functions pretty much. Just this simple argument that there's 2 kinds of force and 2 kinds of fundamental elemental charge bits, and basically everything happens because of how those things interact reciprocally. But 4 simple rules. I mean, it works for me. Anyway, interesting. I don't know. Is that the screensaver? Yeah, stupid screensaver. That's funny. Well, at least it's working. So it hasn't crashed, which is interesting. The camera's crashing. Stuff is crashing, but the actual Linux isn't crashing. This distribution, it's been kind of crashy on this computer, and it hasn't crashed for a whole day. But again, it's not exactly working perfectly either. But anyway, I mean, maybe this video is not working. We'll have to find out. Just trying to find the right camera, mix. I mean, the other camera is just a little too low resolution, but this one's doing the laggy thing. So, yeah, yeah. But I can't run OBS on here, so I can't. Because OBS you can fix the out of sync thing, so I have to find some other workaround. But anyway. Changing the subject, didn't mean to do that. Let's see, all systems function the same. So that's what he says. And I think it's just overtly wrong. If you try to make the universe into one thing, you're going to have a really hard time, I think. In terms of, you still have to come up with the elemental differences. So, and this, like I said, I could give you a theory of what invents an electron and what invents a proton, and I could argue that, yeah, okay, the force bits get caught, going in on an electron, they get caught going out on a proton or something. I can come up with some way to make the 2 things different. But the fact is, you have to have some elemental differences to have function. The universe can't do anything different or complex if it doesn't have something to base it on, and so it has to have some kind of elemental complexity to have emergent complexity. Alright, recognizing charge as the something and something, what is important. Alright, recognizing charge is not, I don't know what that says. Is not something and choosing. Yeah, so yeah, he says pick and choosing. So it's like the David E. Hilster guy. So maybe he should watch the Hilster's videos, because he likes infinity, and he likes to pretend charge is just some sort of, we just arbitrarily put words on something. No, the 2 things fundamentally act reciprocally. It's a really dramatic difference between something positive charge and something with negative charge. It behaves fundamentally differently. It's not some sort of arbitrary or uninteresting phenomenon. I would argue it is the most important thing happening in the universe, is charge. And it does explain everything else. All systems function the same. Okay, that's what he says. Okay. Alright. Charge in charge in more complex, just in and out. So again, he wants to turn charge into just some idea that if stuff is flowing in, it's negative, and if stuff flowing out, it's positive, and that won't work. So I'm just letting you know, it won't. You won't be able to create a system that does that. There won't be any mechanism, or you won't be able to account for the energy. So the property has to be something more fundamental that changes what goes in and out. Alright, just not true. And like I said, if you don't charge the force, there's no way you can take the same force and make it both repulsive and attractive. You're just not going to be able to do it. Just not true, because the Something is infinite. The universe is infinite. Yeah, so that's just kind of stuff he's saying. So and I say I can't see it. I can't tell what I say to that, but obviously I've already pointed out I don't think you can create a working model. Um, and the infinity part, there's no obvious correlates in the big universe to the little one, beyond the fact that there's stuff and it's moving. But that's about, and it has some clumpiness. But there's no other that there's just no recognizable mechanisms of the kind of segregation of function that takes place inside of matter. They're very different things, and they're noticeably different. Let's see, sameness will not create enough difference. System needs something or other. Something, but obviously I've already just said that. I mean, you can't, you have to have some. You have to have some fundamental. Yeah, you have to have elemental differences to have emergent differences. Let's see. So something he says. So he was saying in here. He's only watched like 3 minutes of this video. Then he says, "Well, I saw one of his other videos on magnetism, and he said my model was too complicated." Right? The model where two kinds of force go in and they get segregated, red and black, that's too complicated. The magnet described as a simple polarizing filter is too complicated. I'm sorry. That's just I don't know what to say to that. That can't be meaningful as an argument against, because it's so simple. So I say polarization too complicated, segregation of force, saying black goes one way and the red goes another way, separating tall from short or fat from thin, too complicated. No, that's a pretty simple function. Alright, other systems just also have charge. Other systems that also have change or charge. I don't know what I said. Neutrinos. Well, he started bringing up all this, the BS little particle crap. So he's saying that those things have charge, and and he needs to account for. I mean, apparently, he doesn't say much. He just starts rifling off the litany of silly particles for which again, there's no real evidence that any of these particles have any real function. There's no real solid role for any of them to play in any of the functions we know of. They last for milliseconds, when they're extracted from the atom or from the proton or from the electron. I mean, I guess they don't extract anything from electrons, but they don't have any lifespan. So why are you paying why does anybody need to pay attention to all that crap? I don't see any need. The evidence is that the model works. Yeah, so he says there's no evidence, and I'm like, no, the evidence is whether you have a model that actually explains how things function. And my model works, okay, without having conflicting theories of bent space, creating force, creating movement, and virtual photons. So not only do I not have two different things, fundamentally different causes for movement, I have a cause that actually explains things without saying things like virtual photon, without rendering some magical mechanism. But anyway, so that's my only obligation. Let's see. Oh man, I can't read either. I don't know whether it's like a blood sugar thing or what. It's just weird. I have days like this where everything's just too fucked up. Electrons, magnetism. Yeah, so electricity, magnetism, that's the stuff that needs to be explained. And if you've got a simple answer to those functions, you're winning. If you don't, you're losing. How a magnet works doesn't have anything to do with charge. So that's what he said. So that's where I stopped, as I said, that's just too stupid. And I don't want to get insulting, but it's just too stupid. I mean, it's clearly the idea of attraction and repulsion is fundamental to charge, and clearly that's what magnets do. And there's a clear connection between charge and electricity. Okay, if I charge something, we can see the sparks, we see the electricity wanting to go somewhere, the pressure. And clearly there's a relationship between electricity, the movement of that charge through a wire, and the creation of magnetism. So it's just a completely unacceptable declaration. So we'll play some of this just to get a feel of it. I haven't watched, it's just tedious to watch. Because it really is, he's not making an argument based on anything called evidence. He's just making declarations, one after another, for which I have no reason to believe, because I have seen no evidence indicating that's how it works. No evidence. Zero. All right.
How it works is if there's a flow, let's say this is that particle. If there's a flow coming from this side, it goes towards it and then through it and then out the other side. So the flow is moving in that direction. But then essentially how it functions is then gravity pulls it back, and so it flows in a figure-8 pattern. And so there's no.
So flows in a figure-8 pattern. So this is the same stuff that gravity is supposed to be made out of. And then you say, well, why would gravity pull it back? Because gravity is the same stuff. You cannot make the same force do gravity on the tiny level and then do gravity on the big level. I mean, you can't do the same. You can't do both. Can't make gravity out of something small like photons and then say the photons are moved by gravity. That doesn't make any sense.
Nothing to do with positive and negative.
Yeah, so it has everything to do with it. So you can say, oh, it has nothing to do with it. I'm not going to make a declaration that undoes 200 years of human curiosity regarding the subject of charge and electricity. It's just idiotic to say it has nothing to do with anything. It has everything to do with everything.
Figure-8 flow pattern. But what manifests is that there becomes two poles, because one side is all inlets, and then the other side is all outlets.
Doesn't make any sense. Again, show me how show me again. Draw the model of it, because I'll say you'll end up with horrible conservation of energy problems, because you'll just be making up energy.
And so basically everything's coming in one side, everything's going out the other side by flowing in this figure-8 orbital that then creates the emergent observation of a positive and negative pole. It's got nothing to actually do with positive and negative particles. It's just...
I'm telling you it won't work, so fine. You can say it. You haven't detailed any of it, you're just saying it. I can draw a picture of how a magnet works, and I think the picture's completely accurate. No one's going to be able to draw over it. And, maybe you could try drawing over something I'm saying, but I don't think you'll be able to do it because it works.
Just a manifestation of a flow field that moves in a figure-8 pattern, where then there's one side that pushes and another side that essentially pulls.
Right, that would be fine if everything had a side to it, but there's no evidence that electrons have any sidedness and that protons have any sidedness, that they're positive on one side and negative on the other side. There's no evidence that's real or true. So, fail, I say.
Which then brings about the push and pull effects of magnetism, where, for example, gravity is only pull, even though it's a push by the ether, the way we understand gravity.
So again, by the ether made of what? Okay, fine. You want to say the ether is pushing, then we can say that you're calling the ether force, and I'll call the ether force. You can call the ether. But yeah, my force has to always be moving. It's not a dead ether. It's already got energy moving in a direction. It doesn't do the I'm here but not doing anything thing. Your ether is some kind of medium. My force is something active. If the force is there, then there's a field. If there's no force, there's no field. In my world, there's no ether. The ether has to be on or off. It can't be, both. Can't be a distribution network. It's either there or it's not there.
Like Newton's laws kind of way. It's only a pull or only a push in terms of the ether. but then because it's only one, it then
So again, I'll just point out. I mean, I'm trying to point out how the conventional physics is garbage. I'm really not. I mean, I can debunk flat earthers. I can debunk all kinds of people. But why do I want to waste my time doing that? Why I can ask you lots of questions about the ether. If the ether's there, why haven't we detected it? Explain.
manifests in a second, more complex system. So from a single force that only does one thing, which how we observe it is pull.
It doesn't. That's not how. That's how you observe it. I never observed it as pull. I observed it as push. I feel pushed.
Able to, by pulling, create a push because the flow is pulled through it and then it flows out the other side.
So again, so why even use a word like that? So one minute he says he understands the concept of pressure, and then he says pull is a real thing. No, the concept of pressure is all you can do is remove pressure and therefore create pressure to push something. So you never pull something. It's always the external pressure pushing. The pressure that you didn't make low is always going to, something's going to move from high pressure to low pressure. It's not going to do it because it loves low pressure. It's going to do it because it hates high pressure. It's being pushed.
Side, and so then there's a push in this direction. Coming out the other side, there's a push, even though it's only pulling. So I think.
So I don't know. So he says it's only pulling. So again, I can't understand the pull mechanism at all. Can't make any sense out of it. Why anybody would even bother going there? You can't explain how you pull something elementally. Push is elemental. One thing bangs into another, completely understandable. One thing bangs into another and they both go the wrong way. No, that's totally not understandable.
Based on the little bit that I've looked at his work, is that this is based off of his interpretation of how magnetic fields are caused. I believe, and I don't know what evidence he has. I'd be interested, but I don't know.
I don't need any evidence. Again, what evidence do I need? We already know what magnets do. I'm explaining why they do it. What evidence is there besides the actual facts? And I'm meeting them. I'm creating a mechanism that clearly doesn't need anything very complicated to create the phenomenon. The basic idea is completely consistent with the facts. The basic idea is that a magnet is just a hunk of material that is now a filter. Because of the arrangement of the matter, you turn it into a filter, and the external universe is creating all the magnetism, the energy out. So energy goes in mixed and it comes out segregated. Red out of one end, black out of the other. Electron pressure out of one end, proton pressure out of the other end. And that's the entire mechanism. That's simple. And it completely fits with what we see magnets do.
Identify them. And the two interact with each other reciprocally.
This won't be very long, don't
similar
worry.
force, it's a similar elemental matter element. It essentially gives that element a little bit of forward momentum in that direction, and it expels force in the opposite direction. A little force bit reflects it essentially, and absorbs that other little bit. Now later it's going to lose that, so it's just an acceleration, and it will be consumed by the mass of the universe. Will essentially, by the laws of probability, take that force away eventually. So it only lasts for a little bit. That's why you can't shoot electrons to the moon. It's because they lose their velocity by these rules. And so it's very simple. It's basically an exchange. An arrow going this way goes in and is exchanged for an arrow going out. So you can think of the electron as having arrows in all directions, and it basically makes exchanges. It takes one going this way, and it gives back one going that way, and that means it.
The boat example is probably better than this one, but whatever. It's a simple enough concept. So this is the longest he let my video play, so this is a record.
It has an imbalance in this direction, it moves in this direction until that imbalance is taken away. Same thing happens with a proton when red force hits it. Now when the opposite force hits, that is when an electron force hits a proton, it doesn't change, it doesn't cause any momentum, and the force is merely expelled in some perpendicular dimension. So of the 4 perpendicular dimensions, it leaves in one of those 4 subdimensions. And likewise, when red force hits the electron, the same thing will happen. It leaves perpendicularly. through the simple mechanism.
Okay, and through this simple mechanism, you create low pressure. So the electron lets the proton energy out, and the proton lets the electron energy out, and therefore no reflections can happen between them. So it's the ping pong ball example, all that stuff I've already been over so many times.
Create all kinds of ability to create plus and minus charges. So if you would understand that the two electrons at a distance would have this force between them and it would just constantly be reflecting, and that would be causing constant pressure. Now if you move the two electrons closer, the little bits bouncing back and forth between them will bounce at a much higher frequency. That is, they'll hit the surfaces much more often. That's the energetic event. So in a sense, by pushing two electrons together, you create energy. But you create more impacts because you create more impacts. Just like two ping pong paddles move together with a ping pong ball bouncing between them, the ball bounces faster, and there's more impacts, more energy revealed. Exposed, released, however you want to think about it. So
right, proximity is energy.
Atoms are not as they describe them, in the sense that electrons aren't spinning at light speed around them and doing all this fancy stuff. They're not sharing them in some silly figure eight crap or any of that stuff. They're all magnetic. And so the electrons and the protons essentially...
I gotta stop there real quick. Although it's been supposedly discredited because we don't understand the functionality of the ether, the concept that the solar system is an atom, I forget what's called, the atomic solar system or something, the concept that the structure of an atom is the same as the structure of the solar system is true. It's just we don't understand how it's true because of the way we...
So again, he just says things, right? So he says it's true, but why? Why should I believe that that's true, when in some ways it doesn't make any sense, right? Because the speeds are way too fast, the particles are way too light. None of it makes a hell of a lot of sense. And we already know what gravity does, which is it consumes 99% of the stuff that goes into gravity either leaves in some direction, or it crashes into the sun. I mean, that's what 99.99% of anything that goes into the solar system, that's what's going to happen to it. Either beelines right into the sun, or it shoots out of the solar system for good. But that's how it works. So how does the atom stay together? It just doesn't make any sense as a model, in my opinion. It certainly doesn't explain why two atoms would stay connected to each other if the stuff around them is swirling at these preposterous speeds. There would be no reason for them to remain bound. So I think a magnetic model is much more rational.
Calculate. So like the problem with that model is that if it were to be true, the electron would just spin in and then impact the nucleus, and it would be gone instantaneously in essence. But there's this lack of balance and ignoring the ether in essence that causes that calculation to actually manifest, because essentially we're not accounting for enough. It's too much of an approximation when we make that calculation.
The ether can only take steal energy from something, so it can only act like a friction mechanism. So you can if you make the ether move, then you had to lose some of your energy to move it. And all these things are really subtle, but they're real effects. So I'll go back to the bicycle wheel spinning thing, the gyroscope, and the fact that it will put a torque in the direction of the spin. And it seems insane that all that torque is being created just because the bearings, there's a little more friction on the top bearing than there is on the bottom bearing, just because of gravity. And that's all you're doing, is transferring the energy. So you're slowing the wheel down by moving. So the torque isn't from nothing. The torque is a direct conversion of this rotational energy into this rotational energy. I mean, conservation of energy is a real thing. It's real good science, and an ether messes it up bad.
Calculation that the approximation no longer holds. It doesn't actually manifest in an answer that matches what logic and reason would suggest. And so because the mathematics, which are based on approximations, which don't account for things that we're unaware of in essence, doesn't come out to the conclusion.
Well, if I'm unaware of it and there's no evidence of it, then it might as well just be a fable, in my opinion. So if you just want to say, again, if the model doesn't explain it simpler and it explains it with more mechanisms, ropes, then you're failing. Okay, all you're trying to describe something as simple as something goes from point E to point B at the speed of light and imposes a quanta, a set amount of momentum onto an object. That's what you're trying to explain. Now that's dirt simple. Okay, I mean it can be explained that the little bit just goes the speed of light and it goes in a straight line and then we're done. Or you can make up some complex thing. No, there's a rope and it goes across the rope and it goes through this whole mechanism. No, there's no evidence of that and there's no need for it.
The solar system, that an atom is essentially the same as a solar system, just because our mathematics don't account for things and therefore don't come out to the solution doesn't mean that's not the actual way that it functions, because it is. And so if we want to look at
again, says you. I don't know. It is. Okay, yeah, because you say so. You've shown me nothing that indicates it is. I have no reason to believe it is. Conventional physics doesn't have any real reasons, okay, beyond the fact that they don't have any better explanation. So that's what they settle for. We'll just pretend it's like solar systems or something. Yeah.
look at an atom, all we need to do is look at its solar system. And so when he's saying how these electrons function, well, just look at the planets. That's how they function. How would a planet function if it were to be in...
So I'm arguing no, it's nothing like it at all. The reason that because all the planets are in the same orbits, so that's one reason to say now that theory fails. And clearly, they're repulsive, and they're to each other. Planets aren't repulsive to each other; they're gravitationally tied to each other. So the metaphor breaks down entirely. The electrons hate each other's guts. They got force between them. The closer you bring them together, the more they want. With more pressure, they push apart, just like a magnet. So these are all facts you have to incorporate into your theory. So you can't just say, "Oh, it's just like it," when it's nothing like it. Because I can point out all these things that make it fundamentally different. So I mean, your untested theory of just I say so just doesn't mean anything, because I don't think it will survive any testing.
A orbit between two stars. If it were to be sharing an orbit with between two stars because of the geometric arrangement of the systems and the gravity it feels between them, it would be a figure 8 orbital.
Yeah, says you again. I'm just going to say that no, it wouldn't. If they had any tension at all moving them apart, then as soon as if we shared Jupiter with some other solar system, well, Jupiter's going to spend about 3 years on my side, right, and all the way on the far end of away from the other guy. Why would the other guy hang around? If there was any tension at all pulling the two things apart, it would just fly apart, because why would it say, oh yeah, I'll wait for Jupiter to come back and then I'll be attracted to it and I'll stay? That's not going to happen.
So I'm not sure what he's getting at here, but I do want to point that out, that it really is as simple as looking up to look within.
No, it really isn't. It's physics. It's complicated. And for a theory to work, you've got to go through all of the complications of what you suggest. When you suggest one thing, it breaks the other thing, and breaks this thing, and breaks that thing. It's a little more complicated.
Even though modern theories just disagree, and there's things around the ether, like the Michelson-Morley experiment, that are claimed to be conclusive evidence that it doesn't exist, but there's just this fundamental lack of understanding of the ether.
Yeah, whatever. Again, the magical substance. So it's like just saying a fundamental misunderstanding of the bent space, or the misunderstanding of the virtual photon. I mean, these mechanisms not only don't work, there's no evidence for them.
That brings people...
Dark matter doesn't work logically. It doesn't make any sense. There'd be so much if the universe was 90% dark matter, or if there was 90% more dark matter than regular matter, then we would see gravitational lensing all over the place. See, that's the way the thing breaks. They can't have it both ways. They can't fill the universe full of gravity creating elements and then say, oh no, it's a special kind of gravity that isn't gravitational to photons. Oh, really? Yeah, that's bullshit.
People to those conclusions. For example, the Michelson-Morley experiment is done parallel to the ground, when in reality, the ether being composed, the electromagnetic field being composed of the ether, generally speaking, flows perpendicular to the ground.
So whatever that even means, the ether flows. The whole point is the ether's not supposed to be flowing. The whole point of the Michelson-Morley experiment is that we're flowing through the ether. We're moving. The ether's not moving. That's the current. You're swimming in a dead pond and you're just trying to explain how, well, if I'm pushing through it, aren't I pushing through something? Okay, if the ether can make things move, then when I try to move through it, I have to explain where I got the energy from to move through it. But I mean, clearly the whole point of Michelson-Morley wasn't that the ether has its own generic way of moving.
And so if we were to, in the Michelson-Morley experiment, attempt to detect the ether by using light traveling parallel to the ground when the flow of the ether is perpendicular.
Again, even if I did that, all right, so the rain is falling down and we're talking about moving through the rain. Well, the truth is, if you increase your velocity, you're going to hit more raindrops in the direction of your velocity.
We would not even observe the effects. But it is known that electromagnetic fields affect the velocity of light passing through it, and it depends.
All right, now that's not known. So again, it's just more. He says so. There's no indication that a magnetic field or an electric field does anything to the photons at all. The only thing that slows a photon down is going through matter, hitting atoms. That slows it down.
Dependent on the direction that the light is passing through the electromagnetic field. And the reason that is...
So again, you have no evidence for that. I'm quite certain there's absolutely no evidence for any electromagnetic field causing a photon to do a single damn thing.
It's because it's particles flowing through the ether. And in an electromagnetic field, it's flowing in a specific direction. So if you were to take, say, basketball and try to throw it in a specific direction in a river, then, or let's say something less powerful where it can actually move in one direction, like against a hose. So in one direction, you throw it against the hose, and against the flow coming out of the hose, it will slow the velocity of the basketball. Whereas if you throw it in the same direction as the direction of the flow of the hose, it will actually add velocity. So there will be a velocity difference in the two. The same thing happens with light passing through an electromagnetic field.
Alright, just absolute rubbish. There's just not a single piece of evidence you ever speed light up or slow light down in a magnetic field. So just complete garbage.
Because it's passing through this river of particles flowing, and so when there's a force in the opposing direction, it creates a reduction in the velocity of the particles.
Complete says you mush. I mean, if you're going to say something bold like that, I don't know why you don't cite evidence. You say, well, the Big Bang experiment proves it so. Give me the citation. What experiment demonstrates this crap? They don't have evidence for their crap, right? I mean, they say the photons are bent by gravity, and they cite Eddington, which is garbage, as an experiment. And then they'll cite a bunch of radio telescope crap that's based on insane amount of manipulation of data, to come up with a result. It's a gravitational wave. It's as complicated as the LIGO bullshit in terms of its function, and yet they're quite sure of and quite confident that they've detected something when there's lots of reason to believe it's marginal as an experiment.
And so the electrons and the protons essentially, the protons and the neutrons balance each other's force. So
this is another important thing that's common in chemistry, to interpret the nucleus as being composed of these simple systems: protons, electrons, neutrons, well, protons and neutrons being protons and electrons. and that's just not true. It's a manifestation, in essence, of equilibrium points, where at this equilibrium point, there's balance, and so systems tend towards stability, and so there's going to be these.
Yeah, stability as what though, right? The system is made inside very high pressure. The atoms are made inside the nucleus of a sun, essentially, right? High pressure. And yeah, they have stability in the sense that they don't just blow up, the 100 or so that are able to stay together. But we clearly know that if you do jostle them enough, they do blow up. So they're very unstable in the right circumstance. They'll create a lot of instability.
Sort of not concrete, discrete points where mass tends towards, and so in different points of these discrete points where mass tends towards, there's going to be equilibriums, and each equilibrium will have certain characteristics, and in essence, that's what a nucleus of an atom is a system in equilibrium.
All right, let me just say this. What we know, I think what we know it is a system of positive charge that attracts electrons. I think that's what we know it is.
With its environment that has reached a steady state, that is within like different discrete steady states, and it can change, but it takes enough energy input or output. If it's too energetic around, so if it's
yeah, I don't think it can change. That's why you can't do the whole let's just convert mud into gold. It doesn't change that easy. They're configured packages. If you don't have the exact configuration, the thing breaks down and turns into a bunch of radioactive particles flying at you at the speed of light. So, sorry, no sale.
It's radiating too much, going back to like how charge works. If it's radiating much more than the environment is pushing in on it, then it's unstable, and so it will basically push outward and literally explode, and that's what we call radioactive decay in essence.
Yeah, those are atoms falling apart, so they're not stable if you hit them, break them, but they are stable if they're not broken. But they're not going through any change process. They're either broken or not broken. It's either a Mercedes-Benz or it's a bunch of parts scattered on the highway.
And so radioactive decay is a good example of what's really happening. It's just a matter of pressure, and dependent on the pressure, we'll see specific charges, which is basically balances with its environment, which then leads to the periodic table.
Yeah, I think I'm back. Hopefully. Take a look. Yeah, it looks like it's working. So at least the video hasn't crashed. It's kind of good news, but yeah, it's kind of laggy.
But it's not. It's a single system. If you look at a star, you don't see 7 stars in one clump, all clearly together in a nucleus of stars, because that's not how they function. They function as individual systems.
And again, making comparisons between the big universe and the little universe. The big universe is made out of the little universe. They're not the same thing. It gets more rudimentary as you go down. The blocks get squarer and more wood-like. It's like bricks in a building. You don't think bricks and buildings are the same things. They're just not. You know, rocks aren't highways.
The larger they are, they're still individual systems. The Earth doesn't have 7 systems attached to it. There's nowhere in the cosmos, when we look up, where we see this attachment of systems together as we depict the nucleus of an atom. Because it's not...
Well, except solar systems and galaxies and clusters.
It's not real. It's just an approximation that fits the data sufficiently where we claim that it's real, but that's not how it is. The reality is, look up, and that's
Yeah, whatever. Look, you either have evidence or you don't have evidence. I don't think there's any evidence that I should bother looking at solar systems and galaxies to decide how atoms work. There's just no reason to do that.
how the nucleus of an atom is. Look down, look at the Earth. That's how the nucleus of any atom is. It's not just a helium or a hydrogen nucleus, which only has one proton, but any nucleus.
Well, again, it just has nothing to do with what we know the reality to be, okay? Is that it's not gravity on the atomic level, it's charge. So you're just, again, pretending that Saturn hates Jupiter. And there's no evidence that Saturn hates Jupiter, that there's every bit of evidence that they like each other so much that they annihilated everybody else who was between them.
It's going to have that singular body. It's not going to have 17 protons and 19 neutrons and whatever it may be.
Yes, it is if it's magnets. So if I want to make an arrangement of magnets that have a steady state, okay, where their attractive and repulsive forces keep them in a pattern, I can do that. If I can prevent the magnets from flipping their polarity, I can arrange the polarity in such a way as that the outside magnets are attracted to the inside magnet because they're opposite, and then the other magnets will arrange themselves. I can sprinkle iron filings around a magnet and I can see a pattern form. The pattern is a real tension in terms of pressure. That's what compass needles do. They measure the pressure.
It's going to be one single system that is in a steady state, or not in a steady state, and that's when we tend to call it radioactive, because it's not stable in the specific environment it's in. It's just, I don't know what he's going to say about this, but I just want to point that.
Yeah, no, we know that most things that are radioactive aren't radioactive because of the environment they're in. Obviously, the environment makes, you can make their decay quicker by compressing them. So you put them closer and closer, these decaying atoms next to each other, you get more and more decay. And that's how you make a nuclear bomb, essentially, is to take a bunch of radioactive shit and smash it right into each other so they start decaying each other more often. But clearly, the atoms themselves are already decaying. You can just accelerate how much they decay.
That how the nucleus of an atom is not like this, even if science generally accepts that as factual.
I don't know what you just said there. Clearly, they are accepting this silly model that I think is silly, so fine. They're not accepting it in the sense they're conceding it's not gravity. They're conceding it's nothing like solar systems. Now they're keeping the movement part, which I think is totally unnecessary. And the only part that's really interesting is the fact that there's a clear amount of tension. A magnet will stay a certain distance from another magnet. If I float two magnets on top of each other, we're using a stick, there's a certain amount of pressure the magnet creates, and that's how much pressure it creates. So you know that even if I turn it here, that pressure is the same amount of pressure.
It's essentially, the protons and the neutrons balance each other's force. So, as a simple description of that, you have two, you have the proton of the neutron and the electron of the neutron, and then you have the regular proton. And you can sort of understand that if you have red, black, and red, that means that all the red force can't get trapped between these two. It can't keep reflecting because it hits the black thing and shoots out the sides. Likewise, the red force can't get trapped here because it hits the black thing and shoots out the sides. No black force can get trapped here because the black force all shoots out the red.
I should have made that clear with a bigger drawing that I was comparing these three. You can't really see the arrows. Well, you can see the arrows in my video, so at least I suppose it's a little better. But I should have made that bigger to make it better understood.
The protons. So you create very low pressure, which means they get pushed closer and closer together. That's why the nucleus is so small, and why it's possible to push these charges so close together is because the electron acts as a conduit to allow that to happen. So the basic structure of the atom is that the electrons are at a distance from the proton, and they're held there by the tension between each other. This electron can't move closer to the protons because these electrons are repelling it, and they will not tolerate being put into much more pressure, so this electron is stuck. It can't get where it wants to go. This one can't get there. None of them can get there because they have a conflicting pressure that's keeping them away. So that's basically the structure of all atoms, is creating some sort of balanced pressure. So the atoms that exist
That
formation of the structures are the geometries that are girl.
That's the key.
And so as we have 100 elements, and so there's only so far 100 reliable ways to arrange electrons and protons and have them be survivable. So out of all the possible combination.
It's important, so going back to what I just said, radioactive is high pressure relative to extremely high pressure. So essentially the system itself radiates outwards so much more than the environment pushes in on it that it becomes unstable, and so then it basically at some point explodes because the pressure outward is so high. And
no, you don't got that right either. It's losing the little bits, say, between the electrons, right? So the ping pong paddles are the electrons. They got balls bouncing this way back and forth. There's no balls bouncing between the proton, the paddle here, and the paddle of the proton, because all of those leak out, as pointed out. So all that pressure exists only meagerly. There's no reflections. So you can't multiply the pressure by having the reflected ping pong ball back and forth, back and forth, back and forth forever, trapped. When you start letting that stuff loose, and that's the radioactivity, little bits flying off, the photons mainly, those bits fly off, you start destabilizing the electrons, because now they're not as repulsive because they've lost some pressure, so they can move closer to each other. So it starts to collapse, and once it gets to some point, then the electrons themselves will start falling off, and that's another form of decay. And then once you start losing a couple of electrons, then the whole thing really becomes unstable, and there's a point where they all just break down, collapse, and all the ping pong balls fly out because the paddles are all aligned all over the place, and some of the paddles get pushed out and all that kind of stuff, but the whole pressure system breaks down, all the pressure, the ping pong balls all get free, and the atom has to reconsolidate.
The pressure inward is low enough that at some point it passes that instability point where boom, it explodes. But that's happening because it's on the cusp. But the thing is, so it's high pressure, pushing outward extremely high pressure.
So again, there's no extremely high pressure. It's leaking little bits of energy over time. As it leaks out a certain amount of energy, each atom was created at a different moment in some different galaxy somewhere. They all have a different timing cycle. They're leaking, okay? They were made inside of a sun. They come out, and if they weren't fully formed, like the uranium or say even carbon, one kind of carbon is fully made, it's fully pressurized, it's okay, it's stable. Another form, not quite enough, missing an electron, missing a proton, so it's a little bit broken, and because of that little bit of brokenness, it's not going to survive in low pressure. So once it gets into the low pressure real universe outside the sun, okay, it starts leaking its pieces. And slowly but surely it leaks enough energy to get it to a point where, yes, the magnetic forces collapse, and it collapses as an atom and turns back into the little bits it was made out of. The pressure it was storing from the very beginning.
On a low pressure environment. So what essentially that means is that if you change the environment, you change the stability of the system. So like something that we call radioactive, if you literally take that particle, move it to a high pressure environment, sufficiently high pressure, not just high.
Yeah, I know, but that's just putting it back in the womb. Okay, so yeah, if I put an atom back into a sun, maybe it'll get stabilized because it's in high pressure. But that's the whole argument is yes, that's where the thing is born. So of course, if I put the fetus back in, maybe it'll finish. If the fetus is coming out too early, and I say, hey, you're too early, I shove it back in. Yeah, well then maybe it's going to be a little healthier when it pops out.
Higher, but a sufficiently higher pressure, then essentially it is able to be more at equilibrium with its environment, ethereal environment.
Well, it's more than being at equilibrium. The whole point is as I would argue, is it's not just about equilibrium. Atoms are batteries, and they have to be fully charged. They actually have to mature in their arrangement, and it's only when they're in a mature arrangement that they become stable.
and that can allow it to actually exist in a almost eternal state like hydrogen. It's not like hydrogen is just universally stable. If hydrogen is in a low enough pressure relative environment.
Yes, I mean there's all kinds of hydrogen. So again, you have to. Yes, there's underdeveloped hydrogen, just like anything else. Fetal hydrogen.
Environment, then it too would act as we see radioactive particles act, because it would be high pressure, sufficiently high pressure relative to a sufficiently low pressure environment, that it would basically explode.
So again, it doesn't. That's not really. It implodes before it explodes. So the whole point is it becomes low pressure in terms of the fact that it's how do you say? I've already said it. Okay, it's losing some energy. So in the sense, it has a net loss equilibrium with the environment. But these are tiny losses over time. That's why you can have half-lives that are 10,000 years long or something. It can be leaking for a long time before it finally leaks enough that it destabilizes enough to collapse, and then once it collapses, that's when everything gets free. That's when all the ping pong paddles turn the wrong way and nothing's getting reflected anymore.
Easily. Which is essentially how radioactive decay works, which is the same mechanic as a supernova. It's important, again, all things function the same. Supernovas, radioactive decay, same exact mechanic. And again,
so again, it's silly to say same exact mechanic. It's just, in my opinion, just silly, because we know that the gravity is a one-way force, and so there's no polarization involved. There's none of this electron-proton thing happening. The real mechanism is just the fact that the pressure, okay, the amount of it's made so many of these heavy atoms that it's gained a kind of real mass. So the energy was converted into matter, and as that happens, the sun depressurizes because there's less force bits, less heat, because more of the heat is stored inside of atoms, and so it's just this kind of yin-yang thing. You collapse and then you expand.
Goes back to, that's how nuclei of atoms are structured. They're a single system, like a star, like a planet, like anything we can see with our eyes. That's how the nucleus of an atom is. Again,
it's just silly. Everything I can see with my eyes is of different shapes, all kinds of different reasons why it's in that shape. It's just, I can see a planet, I can see the solar system, I can see the galaxy. Oh, they're all the same thing. No, they're fundamentally different. Some of them are dead flat, some of them are spherical. I mean, come on. I don't want to use bad language, but this is baby talk. It's nothing like the same. You're just not accounting. It's such a preposterous overgeneralization.
It's a single system. It's not many systems conglomerated together. And by many, I mean like 20 to 100. The numbers that we claim that are in a nucleus. Yes, it's many systems in the way that Earth is composed.
So this is the real burden here. I mean, I make a simple video just trying to say, look, this is a mechanism that explains charge, and then once I explain charge, I'll be able to explain to you magnetism. And you just can't get there. You can't get from this simple mechanism that creates pressure, this simple analogy that this is the definition of pressure, okay? Ping pong ball bouncing, reflecting. If you just understand that sometimes energy can essentially reflect, and then sometimes energy can not reflect, right, and leave. I mean, you can understand that, well, if the ball is trapped, that means if I put another ball in, there's two balls trapped, or I can put another ball, three balls are trapped. If they're trapped in there, right, then yes, if I bring them closer together, that trap's going to mean a lot more impacts, and if the impacts are all at the same speed, that means exactly the same amount of momentum. So I bring them closer together, more momentum to move them apart. I mean, it explains the phenomenon of repulsion.
Composed of essentially however many atoms the Earth is composed of. But it's not so little of a number as 17 protons and 19 neutrons. It's made of...
So what evidence are you going to have to explain why, okay, I mean, I'm all for doubting them when they just make shit up, but this stuff isn't that I mean, they measure the mass, and they can actually break atoms, and they can collect some of the pieces. So, I mean, what experiment are you saying that is complete bullshit? Because there's a lot of them that define, like I said, we can separate electrons, we can heat a metal, and we can watch the electrons fly off of it, in the right environment. They're not known things, they're pretty well known things.
Much smaller systems. It's just stability states. We see them as we see them, in essence.
Which would be trillions. There's only 100 that hold together, where the magnets are in the right position, where they can tolerate quite a bit of jiggling without falling apart.
And so going back to what he was talking about, it's that's only the case in the environment that we experience. The same system, like, it doesn't end. Any system can be stable if it's in the right environment or the present.
Well, again, that doesn't even mean anything, but fine. The argument I'm making clearly is that the reason why there's only 100 elements, and that every one that gets a little heavier, they all fall apart. The half-life gets, in milliseconds. Clearly, that's the confining factor here, is that the arrangement has to be explicit in terms of it has to have these elements of balance. And if they're configured with a little too much imbalance, it doesn't work. And so there's only a certain number of ways you can put the Legos together that they're going to be stable in low pressure, that they'll survive leaving the sun. I mean, there might be lots of other elements inside the sun, all right, but they won't survive outside of the sun.
Pressure outward is equal to the pressure inward.
So, I think this covers it as an explanation. So you can understand photons are the electron force, the negative force, and that they're just bits at a distance. So blue light would be bits closer to each other, red light would be bits that come at a greater distance. So the wavelength is essentially just the distance between the little bullets. And when the bullets hit the electron, they create...
So he's close. I would say close. But the best way to analyze the difference in wavelengths of light, red or blue or whatever it may be, X-ray, microwave, is really just literally just density. The density of the systems. If it's high
Again, it doesn't say anything. We know that it's made out of a certain amount of energy, and we know that the density, as you're going to call it, is completely tied to the frequency, and the frequency is clearly how far apart the cannonballs are. So I'm just saying that there's absolutely nothing wrong with my analogy. It fits exactly what we see in the world. So again, if you're going to say it's wrong or close, you have to explain why it's not close, because it's exactly what happens in the real world. That's exactly how the energy behaves. You fire the cannonballs more often, they're closer together, that means there's more per square inch. That's density. Oy.
Mass per volume. Say blue is essentially higher mass per volume systems than red light. So the individual particles that make up the wave, so just like a wave in the water, in the ocean. Wave.
Yeah, again, just like, no, it's not anything like bullshit. The light doesn't spread like a wave in the ocean. Light doesn't do any of that crap. Doesn't get weaker, doesn't get tired, doesn't do any of the shit a wave does.
Even the ocean is composed of particles. So too is a wave of light composed of particles. It's not this wave-particle duality thing that comes from misinterpretation of the double-slit experiment. But in reality, it's just a wave of particles. It's not anything that...
There's no fucking wave of particles. It's just bullets at a frequency, as I said. Why are you saying that's close when your belief system is entirely different? What is wavy about cannonballs? I shoot cannonballs off of a boat. What the fuck is wavy about that? There's nothing wavy about it.
That's not according to what we already know, what we already understand, what we can see with our eyes, what we've seen with our own actual experiences. A wave of water particles is the same premise as what's happening in a wave of light. And
yeah, I'd say there's absolutely no comparison. I've been over it 4 million times, but yeah, no, there's nothing. One experiment, the two-slit experiment, and I've explained how obviously it's not the same pattern. It doesn't do all the things it's supposed to do. It doesn't obey the same rules, and certainly in the single slit it doesn't obey any of the rules. There's no comparison, there's no similarity. So this is all just, you know, bullshit, this whole wave theory thing. You fall for it, fine. I don't fall for it. I'm not that big a sucker. Okay, so it's probably enough for now. I'll probably listen to the rest of it, but there's no point. I mean, he has his own theory, and again, what's my interest in debunking somebody with their own? Somebody could have the pink skirt theory of the universe. What's the point of me wasting my time explaining how pink skirts don't work? You know, it's too faggoty. You know, it just doesn't work. Too homo. Nothing reproduces with pink skirts. You know, they just make cupcakes all day, so it can't work. I mean, I could debunk any kind of nonsense and say, well, what about this, and what about this, and how does it do that? Well, how about drawing me a picture? I can say that all day, but what's the point? It doesn't get me anywhere to prove you wrong. All right, I need to prove them wrong. So anyway, and you know, when you say things like them, then I can prove you wrong. So if you want to defend wave frickin' photons, wavy-tons, then go ahead, show me the evidence of the wavy-ton. Show me where photons do anything other than go from point A to point B in a straight line, and that sometimes there's point B is here and point C is here, so they go from point A to point B and then to point C. Yeah, they hit things, and when they hit things, they go crooked. Yeah, I think I can prove that. Anyway. Alright, so at least we'll see if this video is of any sufficient quality or not. So it's a good little test, maybe.